And we are recording. Welcome to the monthly Python meetup. We're very happy to see many of you here interested in blockchain. We will have two speakers today. First one will be Michael Llewellyn. He will speak about Ethereum and Python, but also he will explain about blockchain. Afterwards, David Akhtari will show us a project called Hummingbot, and it's based on Python, and he'll explain the details. Both deal with cryptocurrency. However, blockchain is much bigger, and I hope Michael will explain it to all of you. Michael, take over the presentation.
All right, we'll do. So yeah, happy to get into it. And again, thank you for having me. And I'm really looking forward to speaking on this. I have not done a Python meetup well, I don't think I've ever presented at a Python meetup, but I haven't been to one since COVID started. So it's good to be back in that environment. I'll start out by saying there is a growing Python community in blockchain. I would say it's not currently the primary language of choice for a lot of people doing blockchain work, but it's very quickly growing. So I'm excited to speak more on it because I personally prefer Python in a lot of cases. I have done blockchain work with Python, so I'm glad to be kind of officially speaking on it for the first time. So a little bit about my background before I get into the talk, just to give you an idea of how I came to be, why I'm even speaking on this topic. Um, my whole story started in high school when I discovered that you can print money on a computer if you run a Bitcoin miner on it. And from there, I very quickly went down a rabbit hole of realizing that Bitcoin and blockchain and a lot of the technology around it had massive potential, which I'll get into for this talk. But ultimately, it got really incited. I ended up going to Bitcoin meetups here in Dallas and got more involved in the community. And it was perfect time, right place. I knew a lot about IT at that point, and so it turned out to work really well. Where a lot of people at those meetups needed help, I was available. Ended up freelancing a lot, and very quickly turned into more of a first part time and then full time gig. So I started doing more cryptocurrency consulting. Got on the news a couple times when they couldn't find anyone else locally that knew what was talking. So they were like, "Let's get this high schooler on." So that was pretty fun. And just basically, as soon as I turned 18, started my own firm, cryptocurrency consulting, and pretty much went from there. It still was kind of just a personal shop for a while, but around 2015, when Ethereum launched and a lot of other decentralized applications, including Factom and a couple others, became more prevalent, I started to get more into like the development side. And this was the same time I was studying for a computer science degree at UT Dallas. So it ended up being a perfect mix. And I realized it was a great niche to be learning. Like I ended up learning more about programming by doing blockchain because I had a lot more context set in my mind for what was going on. So very quickly got a lot more into how we could build things. And so very recently, over the last 2 or 3 years, especially, I've been doing more blockchain software. I really learned how to develop smart contracts and became more of a blockchain solutions architect. I still do a lot of software development as well, but I also like really working on kind of the high level design considerations around blockchain because there's a lot to consider when it's very different than other architectures that come before it that are typically more of a client server model. Blockchain kind of turns that on its head. So in the last couple of years, I've co-founded Tarski Technologies, which is a product development firm focused on blockchain. So me and several other partners are working with several corporate projects. I've worked with Thomson Reuters, Toyota, Verizon on separate POCs or even larger production scale blockchain projects. And then most recently, I lecture on blockchain at UT Dallas. So that's ultimately why I came to talk more about this technology and why I really find it very interesting. So it's been blockchain ever since 2012. So for this webinar, I'm going to talk about why Python can be used to create decentralized applications on the Ethereum blockchain. Decentralized applications very shortly are a way for users to manage assets and information in a trustless manner. So you have a blockchain instead of a centralized service, and I'll explain more about what that means. But really, I'm going to talk a lot about blockchain, but at the end, I'll wrap it up with really talking about what are the Pythonic tools, frameworks, and languages that you can use for smart contracts in this environment. I'll specifically cover Ethereum, but there are certainly other areas where Python can apply, like Factom and others. So, but Ethereum is kind of the big dog out there when it comes to blockchain, so it's a good one to start with. So, with that being said, I'll dig into what blockchains are, what they can be used for. I'll kind of go at a pretty steady pace, but if y'all feel like there's a question you have or something you didn't understand, feel free to stop me. So, we'll get into a nice blockchain primer and really get into what this is about. So I think one use case you can talk about with blockchain, and this gets all the way back to Bitcoin and a lot of the initial technologies, is how do we prevent double spending? How do we prevent a situation where Bob is sending a transaction to Alice for $10, and they need to talk about, basically they need to decide, okay, how do we verify this transaction? How do we make sure that Alice doesn't replay that same transaction multiple times? So, he could, this is a computer, this is a digital technology. Someone can just copy a transaction. They can copy a movie. They could probably copy a digital transaction and resend it. How do we stop this sort of a double spend attack? To prevent double spending in typical architectures, we trust a third party to maintain a ledger that holds a complete history of all transactions. This will be your banks, your payment providers like PayPal. Pretty much everyone says we'll just keep a list of transactions and we'll make sure that no one gets to either send transactions multiple times or in any other way try to cheat the system. So we're trusting someone like a bank to manage that. And even though that works really well, at least initially, it does introduce problems. So we have issues such as, it's a single point of failure. We can have hacks that occur. We saw that with Twitter this year, where people were able to actually send Bitcoin addresses from multiple accounts they hacked into, and it turns out it was like a teenager. So that's a case where a single point of failure didn't work out well. And then we can also have fraud that occurs. I mean, Enron comes to mind when we think of someone cooking the books, but even banks like Wells Fargo have been accused of opening accounts that they shouldn't have and charging users fees. And then in general, we just see a lack of cooperation. You as a developer, you have to integrate with every single bank or payment provider or anyone else that, if you're doing e-commerce, you essentially have to integrate with all these different services, or you're paying a license to a commercial product that does those integrations for you. Like, how wouldn't it be nice if we had something akin to, an email standard for money, or any other transaction we want to make very trustless, rather than going through all these different parties and services, because it hurts cooperation and it makes payments very difficult, in addition to a lot of other systems that rely on trust. So that's where distributed ledgers come in. This is an area where instead of having one person manage that ledger, it is collectively managed by a group of nodes who all will maintain their own copy of the ledger. And so this kind of works similar to a BitTorrent in a way, in terms of someone is able to host a file and then they can share that file with others. And then in addition to that, with the distributed ledger, they'll also communicate updates to each other. So if people are sending you transactions, they'll get propagated and everyone else will know that transactions occurred and add it to their copy of the ledger. So this is how we have to maintain that system. And so by removing the centralized party, distributed ledgers ensure that no single point of failure is in existence, while also increasing transparency. So everyone can verify each other's balances, and we have a far more open system rather than having some closed provider. However, simply distributing this ledger, if we were only going to do that in kind of a BitTorrent fashion, isn't enough. We still need to be able to verify payments came from the right owner. We need to reach consensus in the correct ledger, and we need to prevent the malicious nodes from cheating. So that's where we have to get into cryptography, which is kind of where the crypto and cryptocurrency comes from. So I could talk about cryptography for so long, but like the very short answer is that it is a combination of computer science and math that helps protect systems from attackers, including privacy and identity verification. So it's a core part of how blockchains and even other privacy mechanisms work, such as HTTPS, SSL, and things like that. One core part that's important for blockchains are digital signatures, the idea that you have a public key to identify yourself and a private key to sign things, to essentially say, okay, I will sign this message, and if I sign this message, you can always authenticate that this signature was provided by the owner of a public key. And that's another core part. So I can very quickly identify where a message came from without that person telling me their private key, but I can know it belongs to their public key. So that's another core part of how blockchains work and how we know that we can trust them. And I will actually put a link to the slides right now. Do I have it on there? Yes, I do. Okay, there we go. And then most importantly, hashing functions. We need to create unique fingerprints for data in order to determine them very quickly. So a hashing function very simply is I put in a piece of data and then a unique identifier for that data comes out. And if I make one small modification to that piece of data, then the end result will be entirely different. So it's a very quick way to verify if data is correct. It's very common in computer science for doing indexing or lookups or verifying software packages, but in blockchains, it's very important for verifying that data is authentic and hasn't been tampered with. So using all of those techniques, we can now form what are essentially ways of ordering transactions and actually allowing these nodes to coordinate in a way where they can agree on the truth and continue to maintain that truth over time. So to do that, we need to essentially form blocks in a chain. And essentially, this is so we can establish an order. For example, in the Bitcoin blockchain, we have a block that started in 2009, and that continues up to this day, where a new block is generated every 10 minutes. And conceptually, you can think about blocks as like pages in a ledger book. We know what transactions occurred today in your personal ledger book that you might write down of everything you're doing today. You might also put down the time, but it's really important that you just know they occurred within that day and that they don't conflict with transactions that came either tomorrow or yesterday. So it's just in a way to establish order with a group of transactions. And so when we create a block, we have to put certain things into that block. And one thing we need to do is we need to verify the transactions. So not only will we have a list of all those transactions, but we'll also want to create a fingerprint of those transactions using a Merkle root. And a Merkle root is just a very fancy way of hashing a large set of data so that if anyone modifies the data, then the root will be invalidated and we can easily detect it. So we can keep data immutable. We'll also put in a timestamp so that we know when that block of transactions occurred. We'll create a nonce, which is very important for mining and proof of work consensus. I won't get into that today, but just know that's where consensus plays a role. And the nonce is important for guaranteeing that consensus was reached appropriately. And then most importantly, we'll include a hash of the previous block, which is how we actually end up forming the blockchain. So once we have all these things, we need to start forming that chain and connecting them to each other. So the way we do that is we'll take this, block 101, and we'll link it to the past block. So let's say 10 minutes ago, another block was created. We'll take the hash of that block, so the hash of all the data within that block, and we'll embed it in our block. And that's how we tie the two together. And block 100 will also have the hash of the previous block, and that'll go all the way back to the Genesis block, where these are, block 101 is technically referencing the Genesis block through all the relations of the past blocks. So it's like a linked list in a way. And then furthermore, once we create that, we'll also create another block that will reference the hash of this block. So we start to form this immutable chain that are linked together with these hashes. Did someone have a question? Nope. Okay, sweet. And so an example of why this is important and why blockchains are so potentially powerful is when we change a transaction in that list, we invalidate the Merkle root, and that changes. And then not only does that Merkle root invalidate that block, but it also invalidates the block that comes after. So this is the way that we ensure that a blockchain is immutable and can't be tampered with. And this allows the chain to enforce an immutable order of transactions. So this means that blockchains are immutable, transactions can't be tampered with. It means that they are verifiable. We can guarantee that transaction rules are followed by verifying digital signatures, as well as any established rules that we embed in the code. And then it is decentralized. So there's no single point of failure. There's no single point of collusion. We can ensure that the networks are open and well-governed, reliable, accessible, and most importantly, we incentivize collaboration among different parties. So there's more detail I can go into this, but I think that's a good primer to at least establish how this finally gets into the smart contract and Python part. So with that, let's talk about smart contracts, which are really a way to say, let's take blockchains and let's actually turn them into things we want to program on. So smart contracts were a term that came from Nick Szabo in 1994, and the idea is that it's a computerized transaction protocol that executes the terms of a contract. So if we have some negotiated settlement for how we're going to do a delivery, some logic, which we could write in Python code if we wanted, we want to make sure that when someone runs that code, the result can be verified as correct, and someone's not trying to cheat by either modifying the code or in some other way falsifying the information. So Bitcoin, in a way, is kind of the first decentralized smart contract because it provides one core feature, which is I can send Bitcoin to people in a trustless, decentralized way. So in a way, it's kind of a smart contract for just payments of Bitcoin. But Bitcoin smart contracts were limited because they weren't built for general purpose stuff in mind. You can do scripting in Bitcoin, it's possible, but it wasn't what it was built for. And so this means that there's a limitation on what you can do. But in 2013, Vitalik, who's one of the main core creators of Ethereum, proposed a white paper that would create a blockchain protocol to support custom smart contracts with a Turing-complete language. So a language that would, like technically anything you write in Python, you could also write it in a smart contract on Ethereum. That's the idea. And so through that, you'll have an ecosystem of decentralized applications running with these smart contracts that use the Ethereum virtual machine um, rather than computation controlled by a third party. So this Ethereum virtual machine is actually just a collection of all the nodes in the Ethereum network that can execute transactions based on some code that someone deploys. And so this is a way for us to say, okay, if we deploy a smart contract for Alice to deliver a good, when we verify Alice has delivered a good, we can compel Bob to make that payment based on the conditions of that smart contract. And we're not trusting any third party or any payment provider. We're trusting the Ethereum blockchain and the code that was deployed. And that's the big differentiator. We're not trusting people or companies. We're actually going to trust code on a blockchain. And that's ultimately the core part of what a decentralized application is and what it tries to provide. So very quickly, the way this works with Ethereum is you'll have two types of account. You'll have the accounts owned by users, so Alice and Bob. They'll have a balance of Ether, which is just the cryptocurrency you use for payments, but you could do other things like create stable coins or a representation of US dollars. These accounts can send transactions. They can identify themselves by a public key, and they'll have private keys that control those accounts. So that's how they sign transactions and send them to the blockchain. And then we'll have contract accounts, which are actually going to be where the smart contract is deployed and stored. These will also have a public key, they'll have a balance. And then instead of a private key, they'll actually have code that determines how they interact with the blockchain and respond to transactions from users. So they can be triggered by transactions sent by a user. So for example, let's say Alice is going to send a transaction to mark the delivery of a package complete. So send that through. And then when that's sent to the smart contract, bam, it will change the internal state of that smart contract based on what the code says it should. So when it sees, oh, there's a transaction that says Alice is delivered a good, and let's say only Alice can change that. When it verifies that Alice sends a transaction, it will update the internal state to say Alice has made that delivery. So that's kind of an example of a smart contract. And then from there, it can compel Bob to say, okay, Bob, you need to make that payment. And let's say that Bob put the $10 up, ahead of time. He has no option but to approve that payment and send it through to Alice as soon as he confirms, unless there's some dispute mechanism built in. So this is kind of a very simple idea of what that could look like. So with that being said, I'll give you a very quick overview of what that contract would look like in Solidity, which is a programming language built specifically for the Ethereum virtual machine. So we would define kind of a contract, which looks like a class, but we define it as a contract to say this is like a single smart contract with its own public identifier on the system. So we'll define this delivery service contract, and then we'll define contract variables that will store state that is publicly accessible. So we'll say, here's a Boolean value for whether Alice has made a delivery. And then we'll store an address. So here's the identity for Alice. And then here's the identity for any specific buyer. So this is public data that anyone could look at this smart contract and see to see the current state. We'll define a constructor that accepts a payment from the buyer, Bob, upon creation. So we say this is a payable constructor. And we require that Bob sends 10 Ether to this contract or the transaction will fail. So if he tries to deploy the smart contract and he doesn't put 10 Ether in initially to cover the payment, the smart contract will actually not be deployed. It will fail automatically because the transaction rule, which is this requirement here, was not followed. So a requirement is just a way to just put in a hard stop and say, you didn't follow the rules, a condition wasn't met, we're going to stop the transaction where it's at. And then if the rules are followed, then we save the sender of that transaction as the buyer, which would be Bob. We'll create another function that's restricted to Alice for marking that delivery. So she could pass in a value of status to say that the delivery was completed. Again, we'll put in a requirement to check if the message.sender is Alice. And if it is, then we'll mark that delivery as true, which, by the way, that's a slight typo because I should be just using the status here, but you get the idea. And then finally, let's provide a function that lets Bob finalize the payment after delivery. So we require that both Alice's delivery was made and that the person calling this is Bob, which would be the buyer. And if so, then we transfer the payment to Alice. So this is a very basic example of a smart contract on Ethereum. So, before I go into Python, any questions on that? Because then I can get into the Python part. That was a lot of information very quickly.
I have a question, and my question actually is on the previous slide. You said that it is distributed. So, what prevents the blockchain from being broken? Let's say a computer is down or something like this happens. Like there are multiple copies floating around. How does it work?
Yes. So basically, in the Ethereum blockchain specifically, we can use that as an example. There are thousands of nodes that are running on that network. So, like if we look, let me see if I can find a geos distributed map of that. Let's see. Yeah, here we go. So this is like a heat map. So there are Ethereum nodes located all throughout the world. So over 8,000 of them. So basically, unless you can take down all of these nodes, like the network will continue to run. You could disrupt the network a bit by taking down nodes, but it will not actually stop. And so you essentially have a massively distributed ecosystem where like every single one of these nodes hosts that smart contract, and every single one of them will run that smart contract when a transaction is sent to it. So you have a very fault tolerant ecosystem, as well as a guarantee that none of these nodes could collude because there's just so many of them that collusion would be impossible, as well as the fact that mining, and this is kind of where mining would come in, but essentially the mining ecosystem is also going to make it very difficult to change transactions or falsify them. So you have a massive amount of redundancy that stops any sort of collusion.
I'm sorry, may I extend that question quickly? The same question, but what if a state country does it? Like, for example, let's suppose China disconnect all the Ethereum, mining, and then after a month they reconnected. What will happen then?
So if they reconnected, so if they disconnected, they would be out of sync. So the network would continue as is. If it was just China, especially because they're only 14%, like it would be noticeable, but it wouldn't like stop the network. It wouldn't disrupt it significantly, I'll say. And then if they reconnected a month later, then their nodes would connect, and they would notice that, let's say that we've created 100 blocks since then. Those nodes will recognize that they're 100 blocks behind, and then they will have to sync with the rest of the nodes out there to catch up. So they'll sync in and say, okay, I'll take in these blocks, I'll process these transactions, and then eventually catch up to the rest of the network, which could take a couple of days potentially.
But effectively, I mean, the people in China would continue to use these nodes. It would be their own Ethereum network, and then it would be invalidated for a month, basically.
So you're saying like they don't disconnect the nodes, they only let the Chinese nodes. Okay.
They keep, I mean, it doesn't have to be China. It could be between the Americas and the rest of the world, or some big split between more or less equally networks. And the interesting thing is what happened when they join again.
Okay, so basically, if they disconnect from the rest of the Ethereum network and don't reconnect, that would probably be effectively a fork, which would be a long conversation, but effectively those two blockchains would evolve separately, and that's actually something you don't want typically. And there's actually been a lot of thought put into how to avoid hard forks that aren't approved. But I think effectively what would happen is that the majority of the nodes out there would still be like the proper Ethereum. So if like it was, if it was China, we're talking about 14% of the nodes. The main Ethereum network would continue as is. And if China reconnected later, they would effectively be on a different network, and everyone else would say, your blocks aren't valid because we've already agreed these blocks are valid. And at that point, you would have essentially two different ecosystems running. And most likely what you would see is that the market would recognize that the majority nodes out there are the real Ethereum, and that whatever this Chinese network is just kind of it's a copy of it that have been running in their own ecosystem, but the value wouldn't be the same. And that gets more complex as we talk about it, but I think the simple answer is that the larger network would continue as is, and the smaller network would be considered separate and probably not as valid as it was before.
I think, but this is an attack, right? Like some people could make a lot of money China could make a lot of money if they position themselves to run some contracts that then would go back when they join the main network. But somebody got the money already, so that's what I'm saying. It's Ether anyway, so.
In that case, they wouldn't be able to do an attack. I mean, because the attack would only affect their network, not the main Ethereum network. So it's really a question of like they could attack someone within China, and disrupt their transactions, but they probably couldn't do it to the main Ethereum network unless they could get over 51% of the mining power, which, yeah.
For example, if they get some Ether from a smart contract that's run only in China, and then they, I don't know, somehow they, I don't know if this is possible, but they try to run that same Ether in the American side of the things, would they be able to use it as money in the American side, even if, no, because the American side is not,
Yeah. So that same smart contract could exist on both blockchains. And so, like, if someone did transfers to that smart contract after the fork, it would happen on the Chinese side, but the American side would show that no one had touched it. So they essentially, the only way they could win is if they could insist that someone accept the Chinese version as true. Otherwise, they would just accept the main Ethereum chain as the correct one and potentially couldn't get the money. So it kind of, at that point, it depends on the details.
Thank you. I'm sorry for the long question. Sorry. Thanks.
No worries. It's and there's a lot of stuff we could talk about through that, but the main answer is for the most part, it can protect against it.
One more question, please, before you move on. Eric asked a question, and people like the question, so it's okay. Please ask questions. I want us to be interactive, and I think that David will be happy also if we get questions like this. But Eric asked a question. I'm not sure if he's saying if I should read it, but he's asking: are all transaction smart contracts? Are regular payments just simple smart contracts without additional components, or is it a separate system?
That's a good question. So I conceptually explain that as like Bitcoin's kind of a smart contract, but I would say in the context of Ethereum and most blockchains, a smart contract is a program specifically for managing transactions. And so like a regular payment on Ethereum would not be considered a smart contract. It would just be considered a part of the base protocol. So a smart contract is able to handle transactions related to its state specifically, but transactions on the blockchain network in general that were for payments would not be considered. Like most blockchain people would not say that's a smart contract. I'll say that. So essentially a smart contract are just, they handle transactions specific to themselves. So if I was changing the data in a smart contract, that would be a smart contract transaction. If I was sending you a payment, that would just be a transaction in Ethereum.
But when the block is being generated by the winner, I guess, are the payments included with smart contracts also? Like there's multiple transactions going on in a block, and so you'd have both types of exchanges going on in that hashed block or whatever.
Yeah, it would process both smart contract transactions, payment transactions, and that includes payment transactions initiated by smart contracts, which could also happen. Okay. Which is actually what this is right here.
And that's kind of the basis of people using this for identity, photo ID type 2, is you could embed other things other than financial transactions.
Yep, exactly. Yeah, you can essentially define, essentially what we're doing here with Mark Delivered is we're defining a transaction that says, this person has to be Alice, and then we'll mark this as true. So it's a transaction, it's kind of a custom transaction we're defining for the smart contract.
Cool, thank you.
And
sure thing.
Christopher, you had a question. Go ahead and ask if you want.
Yeah, is Python or Solidity the language that's used most often with Ethereum? If I wanted to get a job with Ethereum, would I learn Python or would I learn Solidity?
Actually, so that's a good question, and I think that's a perfect way to segue into this part of it. But essentially, it would be Solidity on the smart contract side. But the other side of it is you need something to talk to that smart contract, and that's where Python would come in. So there's a library called web3.py, and that's specifically used for interacting with the Ethereum blockchain through a local or remote node. So essentially, everyone's running a node, but you need to actually talk to the smart contract in a programmatic way, and that's where Python would come in. So you would write your contract in Solidity and deploy it, and then be able to interact with it in Python. So like essentially it would be web3.py connects to the Ethereum node, and then that would then talk to a smart contract. It would connect and talk to the Ethereum network, which will allow you to then talk to the smart contract deployed on that network. Does that answer your question?
Oh, hey Michael, I just want to jump in. I don't know if you're familiar with Viper. But Viper is a Pythonic option and Phi was just recently released like yesterday or day before, and it's based on Viper, which is a Pythonic type language specifically for writing smart contracts.
Yeah,
So they're very early stage options, but it is an option if you want to get into it.
Interesting. I had not heard of Phi, but I did throw Viper on here as something else that they have, which is just a more Pythonic smart contract language. One of the complaints about Solidity is that it can be a little esoteric, but Viper is like trying to go for readability to avoid the kind of bugs that you get in Solidity code. But yeah, so and I didn't get to Viper for this talk just because I didn't think I'd have time in terms of like showing you any examples, but you can always go to the docs here to see some. But Phi is interesting. Is that just Phi? F-E-E?
Just
Viper?
F-E, like the symbol for iron, right? F-E.
Ah, interesting. Okay, yeah, I got to check that out.
Yeah.
If you put the website on the chat, people can watch it. So please do. Like the link of the language, because people seem to be interested in usually they don't ask that many questions that early. Eric asks another question. Is Solidity full-blown language or more of a syntax for those object file types?
That's a good question. So it is a full-blown language. It is specifically built only for the Ethereum virtual machine, but it is Turing complete. It does have all the bells and whistles of a proper programming language. Still a little early, I'll say, because it's only been around for about 3 or 4 years. So they're working out the kinks, but by all computer sciencey terms, it's a full programming language. And then 2 other things I'll mention real quick is that there's also Brownie, which is a smart contract development and testing framework written in Python. If you're already familiar with Ethereum, it's kind of the equivalent of Truffle. And then Trinity, which is actually an Ethereum node written in Python, just kind of as a good example. So this is kind of what I was going to show in terms of like how the Ethereum ecosystem works with Python. JavaScript is kind of the favorite for interacting with Ethereum nodes and writing Ethereum tools, but Python is starting to get a lot more support, and there's a lot of actually like core Ethereum developers that are very like interested in Python and contribute to things like Web3.py and Viper, and are trying to kind of encourage that more in the ecosystem. So we're seeing a lot of demand in the industry, and so what I did as well is and let me know when y'all feel like we need to switch over, but I put together an example of that smart contract I showed you earlier, where we have the delivery service. So essentially the same thing I showed you in the presentation. And what I've done is I've got a kind of a demo blockchain running on my computer, which is like a development environment. And I've created a set of Python scripts that we can look at here that actually show us how we can use Web3 to interact. So essentially it's just like a pip install. So you install it. I've got it running in a virtual env right now. And what you can do is import Web3, and the first thing you do is create a connection. So you would say, okay, where is my Web3 provider running? Create the instance of that object and return it. So down here, you can see that we're running on 127.0.0.1, which is just my local host. So if I look here, this is actually a very long version of essentially this is just the blockchain currently running. And what I can do now is essentially say, okay, let me see if I can print the latest block info of that. So if I go up here, I can see that this is just going to print, okay, check the block and print the latest info. So it's just going to tell me what's the last block that you mined. So if I go over here and I run the code as is, and I'll get this printed out, which is not generally formatted well, but you can see things such as the hash of the block. You can see the parent hash of the block. You can see the nonce, which was included. You can see information on the size. So this is just a bunch of general information around the block, as well as like a list of transactions, assuming any had been processed, which actually, because this is running on my local blockchain, it's just showing me the last transaction that I had sent it. So that's just kind of an overall example of like how you can just get general information from the blockchain. So I mean, you could get all sorts of information, like what are your latest transactions, what is your latest block, what's the mining difficulty, what are the fee structures. So you can, using this Web3 library, you can actually query quite a few things from it. But let's say I wanted to talk to my delivery service contract, and I actually wanted to do something like mark something delivered or check the delivery status. So what I could do is essentially deploy that smart contract. And what I've done is I've used Remixed IDE to deploy it. So I've actually got it on the blockchain running now. And it's gotten its own smart contract. So what I've done is when I deployed it, I got a contract address back, which is right here. So if I essentially take this and uncomment it, I now have a delivery contract, and so I'll call this function I've created, which is just going to basically create an instance of that contract using this address. So it's going to say, look at this there's a smart contract located at this address. And then one other thing that I'm going to pass into it right here is an ABI, which just tells me here's like the smart contract interface. Here's like the different functions that you can call. Here are the return types. Here are the arguments. So it's just a way to tell the program, here's how you should be interacting with this smart contract. And then what I can do is I can then call a function on that smart contract, specifically Alice delivered, which is available as a just public function, essentially, to say, like, what is the value of Alice delivered? Is it true or is it false? And I can call that directly. And this is not going to cost me anything. This is not a transaction. It's just me asking what is the current state of that smart contract. So if I uncomment that function as well, I can save. I can run it again. And I can see that the delivery status is true, so that I know that the current status of that smart contract is true. And so I can confirm this by actually going over here to this like interface for it and checking and saying, okay, is this true? Yep, it says it's true. So this is essentially just the current state of this Alice delivered area right here. And so this is actually a smart contract that I had already tested. So let's actually do something different. Let's redeploy this as a new smart contract so that we can kind of get a fresh slate. So I'll basically go to the account, which is loaded on here. I'll go to, I want to put 10 Ether in. And actually, I'll show you what happens if I don't real quick. So I'll delete this contract. I'll hit deploy. And it says, Gastimation says it's going to fail. If I send that transaction, it will fail. Let's just see what happens when I send it. Look. Yep, errored. It failed. So the reason it failed is because we didn't meet a requirement. We did not give it 10 Ether initially. And so the requirement, because that requirement wasn't met, it stopped the transaction. The smart contract wasn't deployed. So if I add that in, give it 10 Ether, hit deploy, I will actually be asked by MetaMask, which is connected to my local blockchain, if I want to confirm. I'll say yes. And bam, that went through. The smart contract was deployed. So that was successful. And now I can actually see that instance there. And now it's starting out with a value of false. I can also see Alice's account as well as the buyer, which I'm treating them as the same just for simplicity's sake right now. So what I can do now is I'll actually go to that little log I had running to see, okay, there it is. Yep, there's that smart contract. There's the contract's address. So I'll change it to this new contract address. Go down here, replace that. I'll save, I'll go back over to here, and then I'll run that same program. And bam, now the delivery status is false because we're talking to a fresh smart contract that has not been changed. So the last thing that I will do is I will comment that out. Actually, no, I'll keep that there for now. I think I can get rid of that actually. And so what I'll do is I'll actually set up a function that will essentially send a transaction for me. So this right here, mark delivered, is actually going to take Alice's account, which I've added in right here. So we're going to say Alice is going to call the smart contract using delivery contract. And then from there, it's going to call the mark delivered function and then pass in a value of true. And it's going to do it from the account and then return a transaction hash that we can see when I print it out to the screen. So this will actually change the state of the smart contract and show us how that works. And so if I hit Python web3.py as is, oh, wait, let me save real quick. There we go. And I'll run that again. Oh, I see. Okay, I'm just going to get rid of this for now. That's not important. Bam bam. And delivery status is true. So it looks like, okay, so what happened, I think, last time is it already ran. It just didn't show me that result. But basically, we did get that transaction, and its status was changed to true. Okay, so I see we've got some questions. Can a smart contract be canceled? Is it a function of the rules of the smart contract in terms of ability to cancel? So a transaction could be canceled in terms of like, if I send a transaction that's going to change, for example, if I try to change the state of this contract, and this requirement isn't met, then the transaction is canceled in terms of the state won't change. Nothing will change on the blockchain because the transaction didn't follow the rules effectively. Let's see. Increase the font. Oh, I apologize. Let me do that real quick. And same thing for this. And by the way, I've added a link to this. So I've added a link in the slideshow that I added into the comments that kind of that give you access to the code in the last slide. But yeah, I mean, effectively, this is what I wanted to show in terms of this is how using Python, you can interact with a Solidity smart contract using this Web3 library. And you can both check the state of the contract. Where's the link? I put it earlier in the slide, but I'll repost it just to be sure. Here we are. So yeah, so going back to the PowerPoint, I mean, really effectively, this, you can find the link here. But yeah, I mean, the code is available here on GitHub, so you can see both the scripts I ran and the smart contract I created. And you can go to Ethereum's Python page to get a little bit more information on what you can do with Python, and the rest of the links here on contact information. But yeah, I mean, going back to the code, are there any questions on the code or the way that what I showed here? Again, I know I'm going pretty quick. If my smart contract does some action at exactly a certain time, I assume the current time can be known from the block headers. Is that time exact? It is exact within the block time. So yeah, so for Ethereum, the block time is actually 15 seconds. So you'll know within 15 seconds when a smart contract executed based on the timestamp that's provided. So if I go back into I can go into, let's see, I'll actually go here and you can actually see if I can find it. The smart contract timestamp here. No? Well, I think I can I can go into the log here, and that should have a timestamp. Yep, there it is. So I can see the block time right there, and that'll give me the exact time that the transaction was confirmed. So yeah, it can be known from the block headers. And it's exact within the time that the block was confirmed, so within around 15 seconds. All right. Any other questions before I hand it off?
Please unmute yourself and say your question, because I think we missed several questions. It's been just running too fast. Many questions. So if someone
I'm sorry.
Go ahead.
I just wanted to know, because in BTC, there is a hard limit to everybody knows, to the inflationary nature of the thing. But in Ether, it seems to be like whatever they want, right? Like the network, guys or Vitalik or whatever. So.
Yeah, it's defined by the protocol. So it's inflationary in terms of, they can't decide on increasing the rate of supply or the rate of creation. But they do constantly create more Ethereum, although they will decrease that amount over time. So they do block halvings, where they'll say, okay, a miner a block will produce, let's say, 20 Ethereum every block. They might cut that down to 10 eventually to increase the supply. And one of the reasons they don't have a hard cap is that Ethereum isn't just a currency; it also is used to pay for fees to run smart contracts on the Ethereum blockchain. So there's actually it's very similar to AWS credits in terms of it actually, you can use it to pay for computation and transactions. So I think that's part of the reason that they didn't want to put in a hard cap. So it's around 18 million Ether created a year. So there is a cap to how much is created. There just isn't like a hard cap or there's a cap to how much is created on a regular basis. There's not a cap on how much will be created over time.
But yeah, because I wonder, I mean, for the case of a smart contract, it would be counterproductive that the whatever Ether it has, the smart contract becomes too valuable. Like, I mean, you don't want to put a smart contract to execute in 10 years, and then you put 10 Ethers, and then it's $1 million there locked. So I assume that it's in the best interest of the Ethereum network to be inflationary in a way that Ether becomes more or less stable in price, right?
Yeah, I think that's the idea. And there's a lot, it kind of goes over my head. There's a lot of like what they call crypto economics at play in terms of how they try to balance out the price. And there's an upgrade to Ethereum coming up where they want to move away from a like mining or like a proof of work mining system, where they want to move to proof of stake, which is instead of people running machines that like essentially are putting in a lot of computational power, they want to move to a system where people are putting down cryptocurrency like their Ether, and essentially using that to validate transactions, so that like if you essentially try to cheat, you'll lose your stake and you would actually earn interest on that. And I think they're going to change the supply rate accordingly because of that change in essentially the economics.
So the decisions like that, how are those made? I put a comment about the hard fork that happened. So,
That's a good question, and that's actually a very interesting area of Ethereum. So the decisions are typically made essentially by the developers of these nodes. So there are weekly core dev meetings that occur where like the whole network is running on nodes, and there's actually several different versions. There's a Geth node, there's a parity node, there's also this Trinity node that is written in Python. And essentially these developers will gather together on a weekly basis, and they'll decide on what changes and upgrades to make to the network through what's called an EIP system. And I can actually, let me pull it up so that y'all can take a look. EIP Ethereum, let me see. Yep. So they have these essentially Ethereum improvement proposals that will occur through GitHub. People will propose them, they'll get kind of community consensus, people will talk about it, they'll define it, and then eventually the core devs will have meetings around what EIPs to accept and which ones not to, kind of based on community feedback. And so it's a very community-focused approach to how these sorts of things are introduced. And a lot of stakeholders have a play: the developers, the miners, the users, the token holders. So it's typically a collection.
It's not a case of just 51% of the nodes decide to do this, and that's the new fork type of situation.
Yeah, typically not. It's typically most of the nodes will fork over automatically to this new protocol. So a hard fork can be all the nodes just moving over at the same time to this new version. And if you have more than 51%, like I would say 51% is like the minimum threshold, but you typically, unless it's a contentious hard fork, like people are disputing it, they'll all do it at the same time, and you won't have too many issues around that. But it does have to be well coordinated.
How big is the network? Just like I'm trying to figure out. Okay, so you showed us the servers, how active they are, how much usage is there, how many petabytes or terabytes does it take? I'm curious how much information it generates and where is it stored?
Gotcha. And let's see. I think is it still sharing my screen?
Yeah.
Okay, perfect. So yeah, so this is a good area to look at. This is etherscan.io, which is like a good way to like pick around in the network and see what transactions are going on. But we can see that like total transaction counter that they've got is there have been over 867 million transactions pushed through the network. And then we can look down a little bit more specifically to see, okay, what have been transactions per day? So we can see that, on Sunday there were, looks like 1 million transactions that went through the network. And like today there were a little over 1 million. And so that gives you an idea. And then like per block, we're looking at like, 188 per 15 seconds. And so you can even get like very granular and like start popping open transactions.
That move to a kind of something that represents reputation is interesting, going through GitHub and developers and nodes instead of just something that could be bought or taken over by, a bank or corporation. So it's an interesting component of this.
Yeah, and that hard fork possibility is an interesting one, because while it's kind of like not great in terms of it can be chaotic if people decide to fork, it is an interesting component where the reason that those EIPs are respected by core developers. The reason the core developers don't just make arbitrary decisions and just say, screw y'all, we're going to do this and you're going to have to like it, is that if there was contention about that, the community that doesn't like that decision has the opportunity to fork and create their own version of the protocol and kind of go on their own. And there's been an occurrence of that with Ethereum Classic, where I think it was around 2016 or 2015 where there was a hack. The community wanted to reverse the hack, and some of the community said they didn't want to because it would violate immutability. This was kind of the we're only going to do this once, guys, kind of situation. But I mean, the people that disagreed with that did in fact fork and kept their version of the protocol where the hack wasn't fixed. So it's an interesting dynamic because you have that option to break off and form your own community on the same protocol. You also have the ability to take the source code and create your own version of the Ethereum blockchain, and a lot of projects have done so. In fact, there are even Ethereum versions of Ethereum that companies will run, and no one else will see it, but they have their own version. I mean, even the version I'm running on my system now, which is this is just my kind of own blockchain, but you could take the code and set up your own network with your own nodes and do your own thing if you didn't want to do it on public Ethereum. And there's even there are test nets that are available where I could go on here and right now I'm running on my Ganache local instance, but I can also choose a network. There's the main Ethereum network. There are test networks that are just running the same version of Ethereum with different configurations to make it easy to do test development. But it's a really interesting area where it's you can do what you want with Ethereum. We have this main Ethereum network that most people work on, but there's also perfectly valid reasons for you to break off and do your own thing.
So I suggest one more question now, but I do want David to start showing his presentation. I see that people still want questions. Sherry asked one question. Answer it and then we'll move on, and the rest of you stick around. We'll have more time for questions later, but I do want to give David the ability to show his. So Sherry asked, what are the examples of consequences do you have with forking?
Okay, so that's a good question. So I think the most immediate consequences, there can be good and bad. The most immediate consequences that are good for people that own tokens on that network are that after they fork, you owe, let's say you were on Ethereum before they forked into different versions where you have main Ethereum and Ethereum Classic. If you had Ethereum beforehand, you now own both Ethereum on, let's say you had 10 Ethereum, you now own 10 Ethereum on the main Ethereum chain and 10 Ethereum on Ethereum Classic, which means that if Ethereum Classic is also trading on the market with a market cap, which it does, you have kind of increased the amount of value you control, because now there are two versions of the same token or the same cryptocurrency, but they're both worth different amounts on different markets. And so there has been a fear that if you fork a protocol too much, then it'll dilute the value of the main protocol because there's these other forks. But I haven't really seen that be the case, at least not yet. It's typically if a fork occurs, the original chain continues on as is and continues to appreciate. But now there's this other version that also makes money. I would say the bad thing that can occur with a fork is that you can lose community cohesion. You can lose people that were contributing to your community or people that were running nodes in your community, and then you lose them to this other fork that will go off and do its own thing. You no longer have those nodes or those miners or those developers, contributing to your ecosystem. So that would be the downside, is that you can lose some of the people that would be participating. And in general, it's the fact a lot of forking occurring. If you're a lot of people are forking from your protocol regularly, then that's an indication that you're not managing your community well. The community isn't very aligned on how they want to continue to maintain it. And Ethereum hasn't had a lot of forks. I think the Ethereum Classic fork is the only major one. I'm not sure if there are any minor ones I'm missing, but Bitcoin, for example, has had 3 or 4 forks so far. And partially, again, I don't think Bitcoin has actually been hurt by that too much. I think it's doing okay, but I think it confuses people that come into the ecosystem and say, oh, what version of Bitcoin should I use? Why are there so many versions? It definitely can be confusing, but in general, I think it's too early to tell exactly the long-term impact it's going to be. I think it's going to be a mix of good and bad.
Well, thank you for the answer. Michael, stick around, please. I want David to give his presentation. I know there are more questions. Keep on the questions going, but maybe David can answer some of them. So I would like to ask you all to thank Michael. I'll clap for everyone, virtually or not virtually. We can put it in the chat. Yeah. Okay. And I would like to switch to David at this point, but stick around. We will have more questions for both of them at the end. David, share us your screen,
All
and
right.
David will also show us a demo at the end if all works well. Hopefully, all the technology will survive this.
Yeah, I mean, how can it go wrong? It's a live demo. Those never go poorly. All right. Well, hey guys, thank you for joining me, and thank you a million to Michael for doing the heavy lifting on the blockchain explanation stuff. Because and Jacob, we got the order correct on the speaker front, because now I don't have to cover any of the stuff that he covered, which I didn't mostly in my slide deck, which is fantastic. So sorry, I just realized I was looking at all your faces and not showing you my screen. Okay, can everybody see my slides now? Hopefully.
You're fine. You're fine. We see your slides.
Okay.
We'll tell you if something is
Great.
wrong.
All right. Okay. Good deal. So, welcome everybody. I'm going to be telling you a little bit about Hummingbot for crypto trading. I'll just give you a brief overview of what we're going over. I'm going to tell you a little bit about me. I'm going to tell you a little bit about crypto. Michael did a great job explaining blockchains and how they work. I'm going to dig a little bit deeper into crypto and what that is, and the difference between traditional sort of native cryptocurrencies and tokens and that sort of stuff. I'm going to give a very high level overview on trading in general. And if you're familiar with trading in the financial markets, trading in crypto is very similar. I'm going to talk a little bit about one of the big differences, which are the types of exchanges. So if you're used to the traditional financial markets, DEXs might just blow your mind, the concept of decentralized exchange. And then we're going to talk a bit about algorithmic trading and how that works. And then finally, we're going to get into Hummingbot and what it has to offer and why you might care. Any questions about that before I go on? All right. So briefly, to tell you a little bit about me and my company, I did my undergraduate in computer science at Michigan, ended up doing an MBA in corporate and investment finance at Duke, did a brief stint on Wall Street at JP Morgan that I didn't bother putting on this slide because who cares. I spent my early career at IBM, then pivoted and worked at Nestle's digital ad agency, and got to do really cool things like shoot a rap video with Snoop Dogg. Since then, I've started multiple startups. I'm currently the organizer of ATX.js, and I continue to run remotely on Node.js and Social Stack developers meetups. And I got into crypto. I became aware of crypto in 2013 and was thinking that I would try to leverage some of my education in finance and computer science, and was looking at possibly doing exchange arbitrage back when there was an exchange in Japan, and I can't believe I'm blanking on the name of it. Mt. Gox, there we go. That for some reason the price was lower than everywhere else, and so that presented a very clear arbitrage opportunity. And we're going to talk about what arbitrage is in a minute. But I peeled the onion on that and found that that was a very bad idea, and I'll explain why later. But net Mt. Gox exploded fantastically, and a bunch of money went missing, and it's still being unraveled today, actually. So I sat on the sidelines and sort of watched, and as Ethereum matured and all of that, I got more and more involved, and eventually launched a company in 2017 called ERC DEX, which was a decentralized trading platform for Ethereum-based tokens. The intent was to be the world's first decentralized stock exchange. We unfortunately didn't make it. We kind of ran out of money while trying to wade through all the red tape and deal with the regulatory difficulties. But in shutting that down, I had the opportunity to open up Discovery Trading, which is what we're here to talk about. Discovery Trading is my trading firm that runs Hummingbot and does crypto trading and market making for our clients using Hummingbot and using Python and the technology that you're going to see today. I'm also core developed on Unitrade and on PegNet. And so if you're interested in either of those projects, I'm happy to speak to that as well. So a brief overview of cryptocurrency. Michael did, as I said, a fantastic job of introducing the concept of blockchain. So I'm sure you all understand everything under the first bullet perfectly. But basically, blockchain as a concept is a public ledger that is meant to be trustless because it's secured by mathematics. So it's computer programs running, if it's a proof of work blockchain, the computer program is running, trying to essentially factor very large numbers, which is a class of mathematical programs that are hard to solve but very easy to verify. And it's a contest. So all the computers on the network are trying to solve these problems. And when one does, it has the privilege of taking all the transactions that have been sent to it, forming it into a block and sending that to the network, and it gets paid for doing that. The person that's running the software that does that process I just described is called a miner. Mining is very lucrative, but now, particularly with Bitcoin and even Ethereum, those blockchains and the technology related to mining on those blockchains is so advanced that it's actually quite cost prohibitive without a lot of capital to get into that. But an interesting note, one of the largest mining operations, I think actually the largest mining operation in the world when it gets fully at capacity, will be right here in Texas. So that's pretty cool. Bitcoin, we've discussed Bitcoin a bit already. For it to be able to do its job and do the work, for the miners to be able to do their work and be incentivized to do their work, they get paid, and the way they get paid is in the native asset of that blockchain, which is Bitcoin, which you all know. That same asset is then used as the currency that everybody knows and loves. Ethereum has a native asset that's called Ether, and it is not the only asset of value on the Ethereum blockchain because, as Michael demonstrated, Ethereum offers a Turing-complete language wherein you can build smart contracts. You can actually create, out of nothing but your programming skills, assets that will essentially be of value and can behave like what we call tokens that people can trade. And so out of this has grown an entire economy of trading. And so that's what we're going to be talking about later today. Any questions about this stuff so far? All right. I don't hear anything.
Wait.
Oh.
Before we jump, I have to say, so how do those assets, like, give us an example of like a token that people trade. Is it like a flower or something? What, like, it has a funny name? How does it look like?
Sure. So there are all kinds of assets that could be produced. And so typically when people are talking about assets and trading assets on Ethereum, they're talking about one of two different types of assets. It's either an ERC20 token, which is essentially just a smart contract that conforms to the ERC20 standard, interface standard. So it has very specific rules for the different functions that are implemented and the way that it interacts with the rest of the world. So it's either an ERC20 token or it's an NFT, non-fungible token. And the distinction there is that an ERC20 token just is fungible, right? So it's just like money. If you get $1, it's the same as any other dollar you might get. If you get an ether, it's the same as any other ether might get. Same with an ERC20 token. And an example, there are multiple examples of this, and they can be used in many different fashions. But if they implement the ERC20 interface, then they're a token that you might trade. So recently, one that made a big splash is the Uniswap token. So if that is familiar to you, that's an example. There are stable coins wherein the smart contract implements the ERC20 interface, and it therefore can be traded, and there are certain guarantees about the security of your assets in those contracts. But if it's a stable coin, there are other related mechanisms that ensure or that are designed to maintain a certain price level for that stable coin. So, and there are many examples of this. So USDC, USDT, also known as Tether, DAI, these are all stable coins pegged at the US dollar, and they use different mechanisms to do that. Some are market-based, some are asset-backed. It just really kind of runs the gamut. But the whole goal for all of them is to emulate the US dollar and be stable with it. PegNet, by the way, I should plug PegNet. PegNet is a blockchain that is intended to have assets that are pegged to not just the US dollar, but also many other world fiat, what we call fiat, or government issued currencies. And it uses a different mechanism from some of the other ones that are out there. It does not run on the Ethereum blockchain. There is a Peg Ethereum token, but PegNet has its own blockchain also. But I'll muddy the waters if I go down that path. So I'll leave it at that. Any other questions?
I'm not sure Sherry is asking. She has something about flats. I'm not sure what she means.
That's a dirty word.
I'm not able. Unfortunately, I can't see the chat and show you.
She said fiat, F-I-A-T.
Fiat, yes. Fiat, the government-backed U.S. dollars, euro, etc. Comes from, I believe it comes from the word faith, that you have faith in the government that they're going to pay their bill, basically.
Go on. I had to understand assets. You explained things that are tied to something like a currency. Thank you.
Yep. So let's get into the types of trading that one can endeavor to do. And by the way, none of this is meant to be comprehensive. This is all very just sort of high level. That I'll touch on some things, but absolutely there are very many ways to skin this cat. So please don't expect this to be exhaustive. But when you think about trading, there are two different things you can think about broadly. One is the mechanism with which you trade. If you have ever traded stocks on the internet, you're familiar with click trading. Basically just, go to your brokerage website and log on and look at your account and see the order book and click buy and you're done, right? That's manual click trading. Separately, there's algorithmic, which if your broker offers an API, you can write software to do algorithmic trading, and then that can be all different kinds of strategies that you might apply there. And I've got some of them down below. But you probably have heard of high frequency trading, essentially using the fact that you have a computer to be able to get in and out of a trade really quickly, potentially trying to front run other traders. You can use AI to basically look at data signals and make predictions based on data signals after you've trained your AI model and validated it and back tested it and all of that. And so some of the strategies that you might employ are, let's say, market making, which is actually what we're going to focus on here. And essentially, if for those of you who are not familiar with financial markets or even crypto markets, a market maker is really critical because they essentially come to an order book, come to a market. Let's say we're trading in a particular market. You're trading, let's say Bitcoin US dollar. So a market maker would come in with a stack of US dollars and a stack of Bitcoin, and sell some of the Bitcoin high. It's basically a Bitcoin market US dollar quoted, right? So they'll sell Bitcoin at 12,000 and they'll buy Bitcoin at 10,000 USD, right? And so they're making money on that spread between the two. And so their goal is to just leave those orders on the book and hope that people will do what's called crossing the spread to buy at that higher price, and then they'll sell it back at the lower price, and they just make money on that spread all day long, assuming the market stays within a band. All of these have their own risks built into them, and different kinds of risks that you got to take into consideration. Anyway, I can go on for a while about market making. Trend following is exactly what it sounds like. You see a trend going on, and so you just assume that there's going to be momentum behind this trend. So if a price is going up, it's a pretty good assumption that the next couple of minutes it's going to continue to go up. So you just buy and hold on, and then sell when you think it's about to turn, or something like that. Fundamentals, you're basically looking at, do I believe in whatever this asset is, and based on my evaluation of this asset, do I think that its value should be 10 when it's currently selling at 2? And if so, maybe I buy now and then, sell when it gets oversold or overbought. Technical analysis is another class where people will literally look at charts and draw lines and figure out, based on technical indicators of that chart specifically, regardless of whatever the asset is, should I buy or sell or what, based on their technical analysis. And then arbitrage, which is something I spoke about earlier. Arbitrage is meant to be, proper arbitrage is meant to be risk-free, in that you're essentially buying and selling an asset simultaneously, and therefore not taking on any risk, because you happen to be able to buy in one market low and sell the same asset in another market high. And so your net is zero, except for the difference in price that you get. So those are some of the different strategies that one can undertake when doing trading. Hummingbot mainly supports, and we're going to get to this later, but Hummingbot mainly supports market making and arbitrage. Any questions about this?
Sherry had this question about whether this is people or AI does the trading mostly.
So click trading is going to be done by people. Algorithmic can be AI driven, does not have to be AI driven. That's sort of the short answer. Your algorithmic trading is going to be a computer program. Whether or not you add in machine learning into that algorithm is up to you.
Can a private person engage into algorithmic trading, and how would it, submit the taxes? It would be a book of taxes, no?
Taxes? That's a great question. So you're getting into, let me come back to that if you don't mind.
Sure.
The answer to the first question is, can a private person do algorithmic trading? Absolutely. It happens. Probably the majority of the majority of the participants in the algorithmic crypto trading market are individuals. The majority of the money is probably not just individuals. But I think the majority of the people involved are individuals. Taxes are a different question, and that probably is its own presentation. But let me get into that after I speak to this. So there are mainly two different types of exchanges that you're going to deal with. You're going to deal with either a centralized exchange, which is most analogous to the traditional financial world. In the traditional financial world, you log on to Charles Schwab or TD Ameritrade or wherever you happen to have your account, and you enter orders. They basically hold all of your assets so that you deposit money with them initially, right? So you have to go through a KYC AML screening, which means that they know who you are. They monitor your accounts. They monitor transactions. They will report to the government if they see anything suspicious. all of that sort of stuff. You're trusting them. It's very opaque. So when they're reporting out volume and things like that to places that care about that sort of stuff, you kind of trust that they're not lying. And this has been a problem in the centralized crypto trading world, where these centralized exchanges crop up all over the world, and they essentially just lie about their volumes because it attracts more traders to their platform. So that can be a problem. They control order book and settlement. So when you hear about crypto exchange hacks, this is one of the problems, is that they're holding all the assets, and they control the order book, they control the settlement, they've got everything. And when they get hacked, they can get robbed blind. But it's fast and easy. People like it because all you do is you log in, you click, 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 and you're done trading if you are a click trader. The counter to that is, because it's all done in the crypto world with assets that are on a blockchain that's decentralized, why not just leverage that decentralized technology so you're not creating a honeypot for hackers? And you don't have to trust this third party to not lose all your stuff. And for those of you who are more libertarian minded, you don't have to go through KYC and AML and worry about your taxes being reported or whatever. So that's what decentralized exchanges can offer. Not all of them do. Some of them do require KYC and AML. We at ERC Dex did when I was running ERC Dex. But the keys there are that you hold all of your crypto assets, or a smart contract can hold on to it, but you can read the smart contract and know what you're getting into before you deposit into it. Everything is peer-to-peer settled, so you don't have to worry about counterparty risk, because again, you've read the smart contract that controls the exchange, so you know if I submit this trade, I'm going to get paid what I say I'm going to get paid, what it says I'm going to get paid, for sure, no questions asked, and no trust involved. The problem with that, of course, is that it's slower, it's more cumbersome, it's more unwieldy. This is getting better with time, but it's still got a long way to go. And then to answer the question that was asked about taxes, if you're trading on a DEX, chances are really good you're going to have to report your own taxes. You're trading on a centralized exchange in the US that is compliant with regulations, which many of them are, I dare say most of them that are US based are, then they will do tax reporting, and many of them, I think, offer reports for you to make it easier for you. But you know, do your own research there, and make sure that you don't make any mistakes on your own there. Any questions about this, centralized versus decentralized?
Someone was asking about OPAC. Can you explain again OPAC?
Hack.
Opaque.
Opaque. Okay, so I was saying, no, the question was, I said opaque, did I mean transparent? And the answer is no, I meant opaque. I mean that you don't actually see what's happening in the background there. You're basically trusting that the exchange that you've deposited all your crypto assets into, let's say you go out and buy, 100 Bitcoin, and you go deposit it on some exchange, you're trusting that the trading that you're doing on their exchange will be reflected and done correctly, and that when you request a withdrawal, you will get your assets. There's no guarantee of that. And you can't see exactly what's going on in the background there. Because quite literally what happens is they're running their own node for the relevant blockchain, and they're just collecting money for everybody. And then they're, sorry, my Amazon Echo was talking. They're collecting money, and then you're just kind of trusting that they're keeping the accounting correct, and that they're following proper procedures with security and all of that. It's completely opaque to you whether or not they're doing that. Chances are good if they're US based, chances are pretty good that they're pretty safe. There are many international ones that are reputable, that are safe, but there's always that chance that something goes wrong, and you're just kind of trusting that. Versus the absolute transparency with a DEX, where you can actually watch your transaction go out and the other transaction come in, and you know exactly what's going on. You can go to the blockchain and say, yep, this is where I sent my Ether. Yep, this was a transaction. I read the smart contract. This is where the transaction was that sent me my tokens back, and I'm good. Like, complete transparency there. Make sense?
Yeah, good explanation.
Cool.
Please go on.
All right. So I know this is probably taking a while. For those who are interested in getting into algorithmic trading, there are a number of resources out there that I'm not going to waste time copying and pasting. Algo trading on Reddit is a really good one. Their FAQ has a lot of really good material. Quantopian is a good place to get started. Generally with algo trading, that's not specific to crypto. That's just general algo trading. For programming, obviously Python and R are both great for statistical analysis and financial trading. CCXT is a library that can be used with Python and a number of other technologies to connect to exchanges, both traditional financial as well as crypto. And then if you're interested in adding a machine learning or AI component to it, I would encourage you to take a look at Flow, the good libraries there. I've got some links in here, and you can go in and dig in further on that. There are also some excellent books that are pointed to in the Reddit subreddit on algo trading that I would encourage you to check out. So finally, we get to Hummingbot. So Hummingbot, found at hummingbot.io, is a piece of software, open source piece of software that is professional grade. I mean, real Wall Street pros use this stuff, or most of them are ex-Wall Street now. They're all trading crypto. And it's built in Python and Cython. I'm curious if anybody is familiar with Cython. Anybody actually use Cython here?
I mean, like a toy example, I have played with it, but not really work.
Yeah. So if you're looking to do high frequency trading, speed is the name of the game, and you don't want to have you want to get as close to bare metal as possible. You want everything that you do is about making things faster. And so when Hummingbot was originally built, it was built by guys who used to be in high frequency trading. And so they were worried about that. And so they built portions of the system in Cython, which essentially is a way for you to write in Python, but then compile to C, C++. And so I'll show you that in the code base. I've heard that recently in the latest iterations of Hummingbot, they're actually moving away from Cython. But it's actually pretty fascinating. If you are a Python developer and you have some application that needs to go super, super, super fast, take a look at Cython. It is interesting, a bit clunky, but does the job and is very, very fast. So anyhow, I digress. So Hummingbot will connect to one or more exchange, and it runs a number of different strategies, but the ones that are most developed, they've actually sunset a couple of them. But the ones that we're going to see today, the one that we're going to see today is pure market making. It can also support cross-exchange market making and arbitrage. And just in the interest of time, I won't go into the distinctions there. And so that is that. So now we're going to go over to the demo. Briefly, I figure I'll just show you a quick look at the code base. I know this is probably hard to see. The code base is Dockerized, so you can run it on your local machine in a Docker container if you're familiar with that. It breaks down into it's very modular. So you can write connectors for different markets. So all of these are different markets. Bamboo Relay is a decentralized exchange. I spoke about those earlier. Binance is a centralized exchange. The one that we wrote most recently is this one for Vinex. So I was just going to show you a demo of that. But essentially, it follows a very clear sort of template, and they've got excellent documentation on how to do all this stuff. And a lot of these you can sort of copy, you literally just kind of copy paste and then refine based on the API that you're actually trying to connect to. So there's not a lot that I'm going to show you here. Not a lot more than I'm going to show you here. Oh, also, I will point out that you can create your own strategies once you understand the framework that Hummingbot works in and how it all sort of fits together. You can start developing your own strategies. And they have a few here that are in development mode. Yeah, I guess I'll leave it at that for now. Oh, and for those of you who are interested in Python, really all it is you build out your Python class and annotate it appropriately, and you set up a definition file. And essentially, when you run the compiler will create your own C++ file for you. So this is our C++ file created from my PYX and PXD files. And then that in turn gets compiled into object files that are the binaries that are then ultimately produced. So here is where I expect everything to go sideways, because we're going to do a demo. And I've got the Docker already up here, hopefully. All right. So the way that Hummingbot works is it's built to use configuration files that are in YAML. So hopefully everyone's familiar with YAML. I've already defined one for us for the purposes of this demonstration called Python peg.pusd. So I'm going to load that file, and it failed. Wonderful. See, I told you it would go sideways. Okay, so let's see if I can create it. Okay. I'll try that one more time. Unfortunately, I made the mistake of killing this VM, and it seems to have totally pooched the file system somehow. So I have to go through and quickly create this, but you'll get a quick tour of that. It doesn't take that long. So we're going to create a new configuration for our Hummingbot, and we're going to use the pure market making strategy. And we're going to use Vinex as our exchange. And the token we're going to be trading is called PEG. There it is. PEG PUSD. That. And that's fine. Okay, so now we're all configured and we can get started. So, by the way, for those of you who are going to do this and are just going to get into it, you'll notice at the top of my screen, I've got paper trading mode off. But if you're just getting into it, you're gonna want to run it with it on so that you can learn how to do this stuff and get used to Python, get used to the interface and get used to the commands. Paper trading mode allows you to have Hummingbot running and acting like it's trading based on the market conditions, but it doesn't actually put real money to work. I have it off for now. because why not? Let's run this. So let's see what happens. All right, so it's going to check to make sure it's connected to the network. I don't know if you can see this, I've got it connected to Telegram. So I can run these trading bots from my phone using Telegram. I can send it commands. It'll update me on statuses and whatnot. Okay, so here we go. We got a bunch of issues with some pairs, but it's ignoring that. That's fine. At the bottom, you can see here that we've created a limit sell order and a limit buy order. And then we can go over to our trading interface. And here we see our sell and our buy. I guess I didn't show you this before to confirm that we didn't already have those on, but you'll just have to take my word for it. We didn't already have those on. So now we're on the order book for 16,000 here, buy, and 16,000 sell here. And what this is going to do is it's going to periodically, if those get bought or sold, it'll then just replace them. There's a whole bunch of different configuration options that you can see here. And we can change our configurations based on these, based on how we see the market working. There's an art and a science to this. What we're doing is actually making markets and putting money at risk here. And your biggest risk is that you get run against on one side or the other, right? So the price goes up continuously and fast. So you have to account for that in your algorithm. And the way that you do that with Hummingbot is by changing some of these parameters. And that's it. I know I threw a lot at you. And I'll just say thank you, and I'm happy to take questions. I'm always looking for projects for our development shop. I'm looking for speakers for our meetups, and looking for devs who want to work on some interesting projects. We don't really hire juniors, but senior devs, we're happy to chat, and juniors I'm happy to help if I can in any way. So that's it. Happy to take any questions.
There were a bunch of questions I saw. I cannot repeat them because things are scrolling too fast for me.
Okay.
So go ahead, guys, ask the questions, and I'll start with my question. What happened to this transaction? Did it sell? Did it buy?
They're going to sit on the book for a while, probably.
This is because it's a big one, or?
Well, so these are limit orders, right? So I'm not going out to the market and saying, hey, whoever's selling, I want to buy it. I'm going out and saying, here's my price. If you want to sell at this price, you can sell to me. And on the other side of the book, here's my price I'm willing to buy at. If you're interested in buying at that price, you can buy from me. But I'm not directly at the market, right? So I'm not willing to do what's called a market order, where I just take whatever is being offered. Does that make sense?
Yeah. And you can do this with multiple, you say you're doing arbitrage, so you can do this with multiple currencies, correct?
You can do it with multiple currencies. You can do it with multiple exchanges. I can have multiple price levels on this order book. I happen to be trading in one pair right now on one exchange, but I can put 5 buy orders and 5 sell orders at different price levels on this particular order book, on this particular pair, on this particular exchange, and then I can do that 5 times over on different pairs, and I can do that again on 5 other exchanges. Yeah, it's infinitely flexible in that way. But that also increases a lot of risk. So you need to know what you're doing before you get that far into it.
Someone is asking if they can get access to the Hummingbot code. Who was it?
So yeah, to get access to the Hummingbot code, all you have to do is go to hummingbot.io and follow the GitHub links. It is open source, so feel free to follow GitHub and dig in.
More questions? By the way, the number of people watching was actually going up during the second presentation. This is This was unusual, but
I've got a question on PegNet actually.
Sure.
I've been following that for a little bit. Is there like I know that it's kind of the DeFi. The way it works is that it gets Oracle prices in, and it kind of relies, at least from what I can tell, relies on arbitrage partially to balance out the market between what's on PegNet and what's on like a normal exchange. Is that been like? Is there a reason you're focused on that? Do you see that as like being a unique arbitrage versus like other normal DeFi crypto stuff?
Well, so yeah, I originally got in specifically for that angle, but Dave Johnston is also a friend of mine, and I know the Factum guys, Paul and all those guys, and so and they were at the sort of they were the founders of PegNet originally, and so this is going to probably bore everybody else, but briefly. PegNet has had issues lately. They've had a couple of different attacks, specifically on the Oracle side. And so they had to shut down a lot of the transfers and stuff. And so now they're implementing staking. And so they're going to look to fix the peg based on the staking side of things. And we can talk offline about it. It's at an interesting juncture right now.
Gotcha.
Yeah.
there were questions before this also to Michael, so all those who are interested in having more questions, because I stopped the conversation at some point so we can get the other talk, jump in, ask questions, both speakers.
Yeah, happy to answer any questions.
Yeah, I hope that they didn't scroll out. Oh, here's someone.
I'm sorry, just, I want to insist on the taxes thing. I'm sorry to be pesky with that, but I just had the experience. I mean, in 2017, I did too many Bitcoin transactions, and then I had a horrible experience with the taxes because I had to report one by one, and it was horrible bad. So I imagine that this Hummingbird program could maybe help with that, at least to, because it's not even easy to you have to tally like the Bitcoin that you buy with the one that you spend, and that's not obvious as it sounds. There are several strategies to do that, and so in the end I had to pay one website to do it for me. So does the program actually have some support for these kind of things?
Not at all.
Okay.
Nope.
I'll add to the tax issues and say that, like, yeah, that's like I've just had to get an accountant at one point. It was such a pain when I was doing it as like a regular business. But I'm hoping like this is just kind of related to the government stuff I'm getting involved in because I'm trying to help get some Texas legislation in to improve that sort of thing. We don't luckily have any capital gains taxes in Texas, so it's not a problem. But on the national level, I've talked with some of the groups at the Coin Center, which is kind of like a lobbying group, but for decentralized blockchains. And so they've been trying to get like a tax fairness act passed where instead of taxing cryptocurrency payments, like they're basically being taxed right now as if you were trading a stock when really it's more of a foreign currency. And so we're trying to change it so that like if it's below a certain threshold, like $5,000, you don't have to file taxes for that. You can treat it like if we're spending money on pesos. So hopefully that'll make things a bit better. But that's up to Congress. So fingers crossed.
And also, if I'm not mistaken, even exchanging one coin for another is actually taxable event, right?
From what I've heard, yes, yeah.
So yeah, that's insane. Yeah.
Any more questions? The discussion can go on for a while, but after we finish the recording. So if no one wants to ask more questions on the record, I'll stop the recording and then we can ask questions off record.
I'm just scrolling back through the chat right now, seeing if there's anything.
Yeah, it's kind of hard. It's like too much. There was like a lot of activity at some point. It's a good sign. This means people are interested, and I see people are interested by the reactions. But it's hard to keep up with all the questions.
I saw one. Actually, no, I see two that I found a vein of questions that I missed. Okay, I'll do it in order. Visa, for example, can process 1,700 transactions per second. Are there any new developments on making Ethereum process transactions faster? Yes, that's a very long answer, but the short version is that there is a move for Ethereum 2.0 where there's going to be sharding. The idea being that we, instead of processing the blockchain transactions all in one ledger, I guess, we're going to split it up into different sections. The idea being you can process in parallel. It's kind of similar to database sharding. And then the other idea is to use payment channels and Plasma and areas where we can process transactions kind of off-chain in a smaller subset of nodes, and then publish kind of the net result or a batch of them on-chain, and just like save transaction cost in that way. In fact, and I guess in a way, Factom is almost like it's a side chain to Ethereum and Bitcoin that kind of does that. It's not exactly the same as some of the other solutions out there, but like that's an example of how like you're doing thousands of transactions on Factom potentially, but it's only one transaction on Bitcoin or Ethereum every block cycle. And then the other question is, what about Chainlink? Can you use it in ETH smart contracts? Yes, you can. That's how you can get external data. I won't get too in detail on Chainlink, but it's a project that is a way for you to basically import data from the external world. So if someone says, we won the Super Bowl today, and you have a smart contract that's essentially based on that event, then you can basically use Chainlink as a way to get that external data in and decide, and basically decide how that smart contract should like settle a bet, for example. So, and so yes, you can use it with smart contracts. And it also has, I would say its biggest use right now is with DeFi projects for getting like price oracles in, finding out what the price is on exchanges.
I have a question that may be not on the list, but it's an important one. I see there's specifically a lot of interest that I hear about from the medical world for blockchain technologies. Can you explain a little bit, this is for both speakers, can you explain the advantages of having this and what can it do that cannot be done today? Just open up a little bit.
I think there's a lot of potential use cases, but the one I hear the most is the idea of like medical records and sharing those. And it gets complex because I think the biggest misconception about blockchain that happens is that people think you have to store all of that data on chain. And I think this gets into self-sovereign identity, which is a really interesting area. But ultimately, I think the way that blockchain is going to enable that, it's going to give people a transport layer to like issue people basically like a transaction that says, I verify that this doctor can view my records, but the records themselves will probably they'll be hashed, and the hash will be on chain, but like the data itself will be off chain, and some other mechanism will handle the exchange of it. So I think where blockchain is going to be valuable is like providing this transport layer to authenticate access to data records, but to give the user direct control over that raw data and not put it on the blockchain. So like healthcare records is like a big area that I think people are trying to go after.
Yeah, I agree. I think the other thing to think about, because I run a dev shop and we know blockchain, and so people come to me all the time with, I want to put blockchain in my blockchain, so I've got some extra blockchain. And my first question to them is, why does it need to be on a blockchain? And you always have to ask that question, because you are guaranteed to be adding a lot of cost and time and pain and struggle and use and all the things to be able to do that. And the main benefit is you look for systems that require trust, and you look to eliminate that trust. You, instead of trusting third parties, you're trusting blockchain and the mathematics behind it. And so a good example, ripe areas for blockchain deployments are areas where industries have had to, just through their function, had to trust one another. And they're not very good at that at the industry level. So blockchain can step in and do a lot there and do a lot of the heavy lifting to do coordination and trust mitigation and things like that. So that's one thing I'd throw out there as far as like looking for places to drop blockchain in where it can shine today. I would say look places like that.
Okay, thank you. This is a good one. So I'll segue to one more question. So what examples of things you don't want on blockchain, and what examples of things you definitely blockchain is good for? Simple examples, just to give an idea.
Don't put a movie on the blockchain.
Yeah. so here's the funny thing. If you'd asked me this last week, I would have said don't put anything that requires a lot of storage because that's very expensive. However, I just heard that a project that has been long anticipated to do exactly that, called Filecoin, is going to be launching this week. So I just heard that meeting earlier today, so I haven't fact checked it at all, and I haven't actually looked into what they're going to be doing. But generally, by and large, you want to avoid very large storage requirements and very heavy computation because it gets expensive. You're paying every time you submit a transaction to the Ethereum blockchain. You have to attach some ether to that transaction, which costs real money. And so the larger the transaction, the more storage intensive, the more processing intensive, the more expensive it is.
Oh, okay, that's interesting. Hearing about Filecoin. Wow, it's really come full circle. For context, this is a project that 3 years ago it got a like obscene amount of money in one of the initial coin offerings. It's got over 200 million, which I think it was like not initially, but it's interesting you say that because I think what I've heard about it is that they're going to use IPFS, which is actually kind of like an improvement on BitTorrent as like a distributed file system, and then it's going to be linked with a blockchain to let people coordinate and pay for decentralized storage. Oh, that's going to be interesting. I've like almost forgotten about them.
Well, it's good that we're having this meetup. We're exchanging things. So, unless someone has a pressing questions, I saw some communication, but I wasn't sure it was a question. Some of the people ask for the slides to become available. If you send me the links to those, I'll make sure that they appear on the Meetup page. And if you send them in the chat here, they will scroll down and people can pick them up on the video. And hopefully the video will collect them. I'm not sure. Sometimes it goes, sometimes it doesn't. Usually we have all videos, but there have been problems with technical issues. And it will take a while to upload this. But yes, for all those who ask, we try to make the videos available. Try. So, unless there's anything pressing, I suggest that we stop the recording. First of all, please thank you again, David and Michael. Thank you very much for your presentations. And if there are no more questions, I'm going to stop the recording. Stick around. It's only a stopping recording and people can start talking other things. Yeah, I'm stopping. 3, 2, 1.